Welcome back. So, lastly left off, we have this little function here that will calculate the value of pi using Viète's algorithm. And the problem is we can only do it with a double. Or a float. I mean, float has less position than a double, so why would you want to? And the problem is that I want to do this with a decimal value. Because a decimal value would have more precision than a double. And the reason we can't do that is because the built-in square root function only works with doubles. So we need to implement our own square root function. So, did a bit of reading. We have an algorithm here. Heron's method for calculating a square root doesn't look that hard, theoretically. So, let's see if we can do this. We're going to start with a double just to keep everything the same, make sure it works. So, S is the number we're trying to take the square root of. Let's see, the initial value of x should be any positive initial estimate. Let's say x equals value divided by 2, that's a popular one. Do this, run this iteration 10 times. Forgot my iterator. There we go. The next value of x equals the previous value of x plus the value divided by the last value of x, all that divided by 2. And actually we can just reassign that to x0. Theoretically, and yeah, you would just run this over and over again until you get the level of accuracy you're looking for. And theoretically, that's all there is to it. So, I want to be able to inject a square root function into this. Alright, so yeah, that's a real word. Theoretically, we should be able to... function should take a double and return a double. And then we can use this incoming function in place of that. And then say pi equals Viète pi. Throw in the square root function as dependency, and then theoretically that should give us the exact same result that we were getting before. Okay? Now let's do that again, but this time pass in our new square root. We're going to use Heron's square root function. let's see what that does. And it does give us about the same value of pi. Iterating 10 times, 10, I just kind of picked a number. It's a nice round number. There has to be a better way of doing it though. Let's do it like this. We're going to subtract the new value from the old value. And we're going to use the epsilon, which is the smallest positive double value greater than 0. If that's true, assign it to x0 and... No, we're just going to return x1. So this will just keep looping until the difference is small enough, and then exit. And then it hangs forever because the difference never gets small enough. That did not work. How many digits do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, about 15 digits. What do I want to put here? Epsilon is too small. 0.1 is too big. I need a better epsilon value. I'm just going to pick a very small number. The difference is very small, then go ahead and return what you have. Oh, I see what I did wrong. Actually, the epsilon might have worked. I'm never reassigning x0 to x1 right there. Let's see if that fixes it. I'd like that to work. And it does work! And now the value for pi is wrong. Pi is definitely not 3.134. That's a little disappointing. This just to be sure. That fixed it. Okay, so we need to make sure we're using the absolute value, otherwise there's some chance that the new value is less than the old by the square root, which would lead to a negative value, which will always be less than the epsilon. So, yeah. That's better. And now, because now we can try getting all of the decimal value, all the doubles converted to decimals. Let's see how far we can go with this. Old square root is out. New square root is the only square root. Need to use decimal values. And then no decimal epsilon. this one might be okay to approximate. Like that. That might be okay. I'm hoping what this gives us is a much longer, like more digits of pi. I want all the digits of pi. Theoretically that doesn't exist, but why should that stop us from trying? And there you go. We have a lot more pi digits. How far does that go with matching a known value of pi, though? Three 3.141 5926 535 897323, and then it gets weird because down here it says 237 and up here it says 846. Okay, what are we doing wrong? So the problem is the problem with the square root function, or is the problem in the pi calculating algorithm? Now one thing here, we can run this counter a lot longer and it should get a better approximation of pi. That's a reasonable request, I think. Let's double that counter. Actually, better than doubling the counter, we'll start by doubling the counter and seeing what it does. Two, 3, 8. Oh, that's not much better. Okay, we're going to do something similar to what we're doing down here. Test the difference between the new value and the old value. And when it converges as far as it can, then we stop. Product is the part that we really care about. So let's say we get small enough, save the new product and break. Otherwise, we save the new product and move on. So this should run for many more iterations until it gets as close as it can get to the correct value of pi, and then quit. Probably. Let's find out. It returned right away. Seven, 9, 3, 2, 3. Oh, this is hard to compare. Let's grab a pile of pi. This will be much easier. And it looks like we have an almost decent match. Those last two digits, though. Why can't I have the correct digits for those last two? Probably because it's a double epsilon instead of... instead of a decimal epsilon. So the question is, what is the correct epsilon value for a decimal? Theoretically, it's twice as much precision. Gonna cheat a little bit. Ask the internet. Does not have a predefined epsilon. No kidding. That's not really helpful. Okay, let's think through this a bit. Float has an epsilon, negative 45. And then the double epsilon is 5e, negative 324, which is about 10 times-ish what the float could do. We're going to try something like this. Let's see. Just gonna stick a 0 on it, which should be correct-ish. Didn't give us a new value though. There must be a good way to calculate this. Oh, here's an idea. That's the value I went for an epsilon. Maybe. It's not giving me a new value though. Try this a different way. If P1 equals P0, then P0 just break. guess I should have seen that coming. It could be... It is the same value, right? Yeah, the 32 here and the 47 here. Now I'm guessing that there's some kind of rounding error hiding in all this math that is keeping us from getting better convergence. Try one more thing. Theoretically, using this value here should give us a better convergence at the square root level. Same number though. Okay, there's a rounding error hiding in here somewhere. And it's probably something to do with the not sure what the phrase is right now, but when you're doing math on really small numbers, computers can get confused. But we did get a lot more digits of pi that are accurate. We're nowhere near the million that I'd like to be able to get. For that, we need even to get the correct number of digits for a decimal, we are going to need either a different algorithm for calculating pi or a different way of representing numbers. Decimals as far as the built-in data types go for .NET. So next time I'm going to see if I can get us a data type for representing arbitrarily large numbers, which should be super exciting. So, until next time.